Hello everyone, welcome back to my channel. Today we are going to solve another interesting problem from the green 169 total DSA problem tracker. In this list, till now we have already solved problem from the array, linked list and matrix. In this session, we are going to solve the problems from intervals, merge interval. Prior to this, we have already covered insert interval problems, which is pretty similar of what we need to solve in the merge intervals. In the following sessions, you can see problem from the interval to pointer, sliding window, string, tree, heap, backtracking, tree, stack, queue, graphs, 1D graph, 2D graph, and dynamic programming. So what is the different thing which I wanted to bring on the table? You can see a number of solutions would be available there for each and every problem on the DSA. But the main thing which I wanted to bring on the table is that when we are seeing problems, my first ask is that whether you are able to calculate the answer or not, right? Whether you are able to get towards the answer or not. Once you are able to find the answer, then it's quite easy for you to build a solution which is optimal. First, first important task is you have to come up with a solution, and then the optimization you can add a number of things so that you can optimize your program. But first important trick is you have to find a solution. Okay, so without further ado, let's get started for the merge interval. So given an interval, when interval I containing start and end. For example, if you see these intervals, there are mainly start and end pointers in the items in that. Start contain the first start of the interval, and end is second is the interval end. Merge all overlapping interval written on in array of a non-overlapping intervals that they cover the intervals to the input. If we see this problem, right, 1 3 2 6 8 10 and in the answer you can see 1 3 and 2 6 got merged, and we can convert, right? First element of the minimum element of both of them, it's 1, and maximum between both of them is 6. So we have already solved a similar problem where we were adding inserting the intervals and we just merging all of that. Right now we have given different, the scattered element over here, and we have to merge all of them depending on whether it could be mergeable or not. How we can think that it is mergeable or not? 3 and 2, if we compare 3 and 2, 2 is always lying between in first interval, it is not gone on the second interval. So on similar fashion we have to find for all each and every element inside my intervals. So what is the first task that I wanted to solve, right? So first task is simple, that I wanted to find that whether I can do that. So in this you can see all the elements are sorted, here you can see all the elements are sorted, but here you can see in the third example you can see it's not sorted at all. So my first task is simple, that I need to sort the element, right? I need to sort the element, and in the second I will be comparing with the first element with the second, with third and fourth, and so forth. So you can clearly think like, I need to sort it first, then secondly I will start from the first or where the smaller element, from the left side, and we'll try to go on the right side one by one. The comparison would be starting first element up, right? Comparison will be started wherever our ith element is afterwards. Okay, so I can think about optimizing it in second term, but firstly I can think about a solution. Like, firstly I will do the sorting, right? Sorting the array, the intervals. Okay, I could, easily able to do that, and then just doing the comparison to find the correct match, find the correct match, and fit that correct map overlapping intervals. And in the last, you can just insert everything in array and return it, and return the result. Okay, so these are the four steps. If I'm able to follow that, then I definitely think that I can able to solve that. Right now I will just give you the, step-by-step guidance, step-by-step explanation with the help of example. Now let's try to think about the example. For example, if we see like, our intervals is that, sorry, just a minute, interval is equal to, sorry, okay. So if we see the first example is 1 3, second is 2 6, third element is 8 10, and fifth is 15 18. So if we see, and when we would look for the output, its output is this, and this can easily get merged, because if we compare this is smaller, but if we compare this and this is not smaller. So anyway, right, 2 is lies between 3, so we can easily able to do the comparison. So output would be 1, and which is maximum between both of them. Can we compare 6 with 8? No, it's smaller. Can we compare 15 with 18? No, it's smaller, so it works. So this is my output. Okay. So as we are thinking about the approach. So what we are going to do the first step, because we want to do compare the neighbors. Comparing neighbors. If it is ascending, then it's easy. If it is not, then you have to iterate in the entire interval. It will be quite difficult. So what I will do, I will just sort it first. So when I sort, right now, if this is my matrix, this is my input intervals, it won't be changing anything, because anyway it's a sorted only. So I will just try to copy that. 1 3 2 6 8 10, and then 15 18. So this is same, right? It's not gonna anything. Now what I will do, I will start with the first and will try to compare everything, right? I will start with this and I will try to insert that into my result. So I will just going to insert into result. My result now contain 1 and 3. Okay. And in the following session, what I will do, I will start my second loop from here, I plus 1, so that whatever the element at, for example 1 3 here, or it could be started comparing from next onwards, because we have already sorted element. So right now our result contain this. I will try to get the second element of that. So how I can get, if I'm storing a result, we always know that whatever the last element we have inserted, we can get that using the result dot back. Okay, so if we use the function, then I will be able to get this with this entire, and I wanted to a second element. So if we go for by the index, it's 1. Just try to compare it with the second element, first element in my intervals. So I will compare with 3 with 2. So is the condition is matching? No, it is not matching, because 3 is anyway greater than 2, right? It means that 2 is overlapping intervals. So in that case, what I will do, I will just try to get the minimum between both of them. So minimum we already fixed. When we have to find whether it's matching or not, right? If it is not matching, then what I will do, I will straight away just do the maximum of 3 comma 6, which is maximum 6. So I will replace this with 6. I will replace with this. Now this is already covered, so I will try to move to the next. Okay, and then that's when we are completing that, we have to make sure that we are moving our index, so that we will not using the same. In the next run, what we'll do, we have 8 and 10. Right now, what was the last element we have inserted is 6. So I will try to compare. 6 is greater, sorry, 6 is less than greater than yes. If it is yes, then I will definitely going to get index increase, and I will straight away insert that, because we didn't have any comparison which is making sure that is present, it's overlapping or not. So what I will do, I will insert 8 and 10. Again, I will try to compare 10 with 15, which is anyway not working, so I will insert the last. So this is how simple it is, right? I will insert 1 3, I will try to compare, and I will replace it with 6. Then again I will insert 8 and 10, I will try to compare with 8 and 6, which is not even comparable. And in the last, I will try to compare 10 with 15, right? Which is not matching. 15 is anyway greater, so I won't be doing anything. I will straight away add that into my result. Once I got that, I can straight away return my result. What we are going to do here, right? We are just firstly sorting it, right? So you can see we are doing sorting first, right? We are doing sorting. Then secondly, we are starting first for loop, and then we are starting again for second for loop, starting after I plus 1, so that I will not, I won't be using duplicate element. And then I will do the comparison for each and every element inside the second element. So what is the overall time and space complexity, I can think. But without that, let me try to solve that in front of you, so that we all are on the same page. Okay. So what I will do, firstly, I will just make sure that I am just sorting that. Okay, this is the first thing which we are going to do that, so that whatever the element should be, the comparison should be happen to neighbor. Secondly, what I want to do, I wanted to do the comparison. Firstly, I am expecting output to be written in vector of vector, so I will just create the same result return type. Now I need to do the comparison. From where I need to do comparison, I can start from the first index itself, because I don't want to do comparison again. I will start from first index. Okay, now we know that we are doing the comparison, so I will just try to get start interval, because I have to do the comparison for each and every element. Intervals of is equal to intervals of I and then the first. Okay, integer end intervals, intervals of I and then the first element. Okay, so this is my start and this is my end, right? So let me just make the correct intervals. Okay, this is start interval, this is end interval. So and the following, I will just try to compare with that. With whom? With the next element of that. How we can go to the next element? Just making sure that I'm just increasing I 1 plus 1. And if for integer j is equal to I plus 1, j is less than intervals dot size and j plus plus. Here what I will do, I will just try to do the comparison. I will just try to do the comparison on the basis if the element contains anything anything less than the element which is on the right side. Okay, so my first comparison, if, right, my first comparison will be if my current intervals of j, right, and that to be the 0, right. So if I start to compare, right, intervals of j, right, j means the next and the first element of that, with the first element of, with the second element of the first interval, so with the n intervals. Okay, so if it is smaller, right, if it is smaller, it means that we can add and we can change it. But if it is greater, then we will straight away, yeah, if it is interval is smaller, then what I will do, there is a 100% I'm sure that it could be a changeable. So what I want to change, I wanted to change the end interval. So end interval, right, end interval we change to max and interval and intervals of j and compare with the second element, so that I can just match that. And if else, right, if it is not matching, right, if it is, we found that it's greater than or is equal to, so does it make sense to compare that? Does it make sense to compare that? Here we can consider the less than or equal to element, so I need to make sure that I'm using the equal to. And if it is not, right, I don't want to do the comparison, I will straight away just move out of this index. And if it is, right, if it is the case, right, if it is the case, then I have to increase that. Once the entire for loop is done, once the entire for loop is done, then I have to insert that, right, I have to insert the entire result. So I will just push back whatever the element we have found. Okay, so start interval and end intervals. Okay, so what we are doing, we are just creating start interval, end interval, just adding that. Okay, okay, I'm just making sure that I don't have typo, so I will copy and paste it. Okay, so once this is done, right, once this is done, then we have result in place, and I will just wanted to make sure that I'm just returning the result, put everything, and then in the last we can just return the result. Let me just try to submit it. Okay, so there is a typo again. Okay, yeah, it will anyway, will try it, no doubt. I'm starting from the I and I will try to compare right side. If it is matching, then anyway I won't be considering that, right? There was again a typo. In your coding, there are high chances that you can see no, that it could break at multiple places, right? So right now, no, 2 6, whether we are doing that calculation or not, irrespective of that, it is going to get inserted duplicate. You can see 2 6 is getting inserted because we are not skipping any interval. We are just trying to make sure that if it is already present there, if it is already there, then we are already inserting that. So there is a condition which we need to check. If it is already exists, right, 2 6 is already being considered, then we don't want to consider it. So if result is not empty, right, if my result is not empty, right, and my end intervals, right? My end intervals is, right, my end interval, like what was the enter into 6. If it is containing the last element, right, end interval is this, and if it is already being considered, how I can check? Result dot back, and that to be the first element. If it is matching, right, if it is matching, then what I will do, I don't want to do the comparison. I will straight away just ask to continue without it. I don't want it to consider because, for example, if we see here, 1 6 6 is on the last, and if it is, the current element is 6, so in that case I don't want to consider. I will just wanted to make sure that I'm just skipping that interval anyway. Okay, so there is definitely a typo. Yeah, what else is pending? Okay, yeah, so yeah, there was, yeah. So because if we are already covering, then it doesn't make any sense to consider that. That's why you can say the continue. We'll skip that iteration, right? Now we got the solution. Now let's try to find the time complexity, and let's try to find the space complexity. So time complexity is the firstly we are doing sorting. So it's clearly O of n log n, right? Plus we are doing this first iteration, and we are just doing the second iteration. We are doing the first iteration, and we are doing the second iteration here. So it's O of n square. Okay. So which is maximum between which is maximum, right? O of n square is always greater. So that is O of n square. What is the space complexity? So we are using a different data structure to store and process. So it's O of n. If we are all the intervals are sorted and we don't need to do anything. So this is the brute force, right? If we think along, right, we wanted to do the comparison for each and every element, then we will be using couple of loops to just make sure that the first loop will compare for each interval, and then second will be doing comparison for 2 6 8 10 and 15 18, right? Now moving along with just optimization of that. So what we did, like, we were doing the comparison for each and everything. Does it actually require to do the comparison for each element and let's try to move on? Just do the comparison each more along. I don't want it to do the iteration comparison for each and every element. I can get rid of that. I can easily get rid of that. So what I will do, okay, so I will keep this as it is and just move a lot towards our iPad. So right now what we are doing, we were using two loops to just do the comparison. Right now what we'll do, for example, this is my input. This is my input 1 3 2 6 8 10, and then in last 15 and 18. So what I will do, I will try to insert this, or I can start from this. If the result is already empty, right? If result is already empty, then I will just straight away going to insert this. Okay, so if my result, I'm considering my result is empty, so I will insert this into my result, and in the second run what I will try to compare, I will compare this with this. Okay, if 3 is less than or equal to 2, right? If the condition is matching, right? If the condition is matching, then whatever the result we have already inserted, it needs to be modified, it needs to change. How? So we know that we can easily able to get the last element out of inserted element in the array. So result dot back will just give me the entire array, and that the first, and needs to be changed with this 3 and with the second maximum of that. So I will be comparing with maximum of 3 and 6, and I will replace that. So in the second run it will get replaced with 1 6. It will get replaced with 1 6. So we have already covered this, right? We have already covered this. Right now we will move along, and I will try to compare 6 and 8. Is there any matching? It is less than equal to no, so I will straight away insert 8 and 10. Then again I will do the 15 and 18 for that. So this is my output. So what we are doing initially, we have used two loops to just do the all stuff. Right now I'm just using one loop to do the all the operations. So what does it mean? We are getting rid of O of n square. We will easily able to do it O of n. So sorting is anyhow we have to do, because without sorting we won't able to get the answer, because that's why we will able to compare. So we will do the sorting first, and the second iteration will starting from the first base condition, and we'll try to see whether that particular result is already included or not. If that is already included, then just try to compare whatever the result last element is there, and if it is even comparable, to make sure that we're adding that straight away or not. Okay, so I will do no small corrections which we have already done. So I will just use the previous vector which we are going to return that, and then I will just start with the interval size on that. If, as we check, right, if result is empty, right, If result is empty, then what I will do, I will just push the entire intervals in that. So whatever the entire result, right? For example, we added 0, so result is empty, so we have to insert the entire intervals here. So I'm gonna insert everything. If not, right? If not, it's not, means for example result is already there, and there is unso condition, right? When we are making sure that we are just managing the comparison, if it is matching or not. So for that we have to do the one more comparison, like as I have seen, as I have explained you here, that we were comparing whatever the element we are inserting, 3 with the 2, right? If it is less than equal to 2, means 2 is already 2 needs to be overlapped, 2 needs to be merged. So in that case we are moving here. If it is greater, right? If it is greater, for example, if we compare 10 with the 15, 15 is already greater. So does it make sense to do the comparison? It's not. So we will straight away going to add that in my result. But if it is changing, right? If it is changing, then we have to add that. We have to change the changing parameter. So how I can change the parameter? If it is not matching, right? If it is not matching, then what I will do? I will just try to see, right? If it is not matching, then whatever my last element was there, right? Whatever the last element, I can get the result dot back. And what is the second element in that? I will just try to check whether it's greater, right? If it is greater, right? If it is greater, it means we don't need to do anything, and intervals of I and that to compare with the 0. So if it is greater, right? For example, last element is smaller, right? For example, so I just need to change the condition. Okay. So for example, if we compare 3 and 2, what was the last element? 3. 2 is currently the 2. So if 2 is greater, right? 2 is greater. So are we going to consider it? We just need to do the consider for greater. If 2 is greater, then we will straight away add that. If not, then what we'll do? If not, then result dot back, we need to just update the second element of result. How we will be adding? Just trying to finding the maximum of result of last element of the first and current element of the intervals of I and that to the second element. And I think with this, we just try to make sure that we are returning the result. I will just format to the formation of that. Yeah, so you can see if the result is empty and result of last is less than, or the result, the current interval, in that case we are adding. If it is smaller, then we will make sure that the element is lying in between the map overlapping merge intervals, and we will be merging that. Just try to submit this now. We'll see if there is any error or not. You can see we didn't get any error. Just try to submit this. Okay, so we can see that we got the output. Right now let's move along for the finding the time and space complexity. So initially we were doing two iteration to just find the merging intervals. Right now we were not able to do the extra intervals, so we can easily able to do O of n log n plus O of n, which is a maximum between both of them. It's n log n. And the space complexity, we are using the different result to store and then process, so that's why it's O of n. Can we see a further improvement over here? Right? Can we see a further improvement over here? I can think of it, because the result, we are just doing the comparison with the result. Does it make sense for me to do the comparison with the result? If you ask me, for doing the comparison result, I don't think so we should even think that I need to use that interval for the comparison. What I will do, I will just get rid of this. I don't want it to use, and instead I will just use the index. Remember that when we are doing that, I will just do a simple modification, or in this entire loop I won't be changing anything. I will be using the same stuff. I don't change anything, I will be using the same stuff. What I did, like I just declare index as 0, and then because we are already having the first index which is in comparison, so I won't be changing anything. Initially what we were doing, we were comparing with the result is empty. Right now result, we don't have the result, right? We don't have the result. And also we definitely need to do the comparison, but not with the back. So where we need to do the comparison, we need to do the comparison with the last element of this, with whom? With index. With whom? With index. And the last element, not the first element. Is it less than equal to? If it is, right? If it is in same, right? If it is same, right? If the current interval where we are, right? If it is same, then what we are doing? If it is same, right? we are just making sure that we are assigning the same element to that. And how we can assign in that intervals of index, whatever the element we are having currently. And if it is the case, right, we are already consume, and we can, sorry, we just need to increase it before. Okay, so what I did, like, I just inserted same element because it is making sure that my interval is greater, so I need to move along for the next state comparison. I won't be using the same comparison for doing. If not, right, if not, what it mean, right, my index, right, result is already, for result 1 3. If I compare 3 with the 2, what it indicates that 2 is already lying between, 2 is smaller than the 1. So in this case the condition will fail and it will try to go here. So right now what we are doing, we are just trying to do the comparison for the maximum. So I will just try to go here and we'll just change that. Wherever we are using the result dot back, I will just try to do the comparison index, and I will just try to insert that. In the last, right, what I do, I just did index and just the second element of that compare with the first index and the i's index. If anything between both of them is greater, then anyway we are replacing that the max, and we'll replace that with the second element. Now in the last, if we just return the interval, if we just return the interval, let's see what output it I'm going to get from this. Let's try to submit it. Okay, so we got, but you can see, like, 15 18 is getting repeated over here. If we see like 4 5, which is, we already got the answer, but it is still getting repeated. Even here you can see we got still got the answer, but we are repeating because whenever we are moving with the index, we need to make sure that we are resizing our intervals. So I just need to make sure that I'm just resizing that. And because under index is 0 base, so I just need to make sure that I'm resizing it with the index plus 1. I think, I got the answer. You can see for all the test cases, it is not getting printed for the last. Let me try to submit this. Okay, so I think, no, I'm able to solve this right now. Move along for the last and important thing, like finding time and space complexity. So we are going to sort this, and we are, having the complete iteration from I to n. So 1 to n. So anyway, we are iterating of n, and we are sorting. So n log n is the average time complexity for this. So what is the maximum between both of them? It's n log n. What is the space complexity? So earlier we were using a different data structure to store and process. Right now we are not using different data structure. We are using the same data structure with which we have received the input, and we are just remodifying the input array which we have received. So in that case, are we using any different data structure? No. So the space complexity would be O of n, right? With this, I think we will close this video. We'll try to see in the following video with a similar and different type of question. Thank you. Bye bye.